Alright, this unit is going to be on density, and density describes how closely packed molecules are in a given sample. Density is the relationship between mass and volume. And so, because it's a relationship between mass and volume, its units are either grams over milliliters, or grams per milliliter, or grams per centimeter cubed. Okay, so it's a relationship between mass and volume. Your mass is your grams, and your volume is your milliliters or your centimeters cubed. So if we look at this diagram here of the smiley faces in the boxes, the picture on the far right, this represents high density. Or in other words, more molecules are packed together in the same space. If you look at the one over on the far left right here, this one would be less dense because there are fewer molecules. Packed together in that same space. Okay, the one in the middle is just kind of in between. You could look at this as a solid, liquid, and gas. Okay, so you could see the different densities of the different states of matter, but I'm going to show you in the next slide that even your different liquids or even your different solids can vary in their densities. Also, we need to remember that density is an intensive property. And that is because density does not depend on the amount that you have. Okay, so it doesn't vary. For example, if I cut out this section of this box, the density in that little section is going to be the same as the density in a bigger section. Okay, these two sections, or these two chunks, are going to have the same density. Now, they're definitely going to have a different mass, they're definitely going to have a different volume, but the density is going to be the same, and that is why it is an intensive property. Okay, it does not depend on the amount that you have. So I said in the last slide that even within your states of matter you can have a huge variety of densities. This diagram is showing you a beaker with 3 different liquids in it, and those 3 liquids have 3 very different densities. Now I'm going to kind of draw what those densities might look like. Okay, so this one on the bottom, if I zoomed in a bunch on that liquid, the molecules in the liquid on the bottom are very dense, they're very tightly packed together, and so I would maybe draw it like this. Okay, it's still a liquid, there's still some space, but it's a very, very, very dense liquid. The liquid in the middle is a little bit less dense, and so the molecules of that liquid are less tightly packed together. Okay, so maybe it would look like this. And then the liquid on the top has the least amount of density of those three, or is the less dense. And so its molecules are going to be even less tightly packed together. And so when you have varying densities of liquids like this, you are going to see those different layers. Okay, it's going to separate like that. Alright, we need to be able to calculate density. So the formula for calculating it is density equals mass over volume. And from now on, I'm just going to write it as D equals M over V. There's an easy way to remember this equation and to manipulate it, and that is if you draw a triangle and a T inside of it, and you put density down here, mass on top, and volume on the right hand side. And so what this shows is that, let's change my color. Density is mass divided by volume, okay, right here. You could also look at it as volume is mass over density. Or you could look at it as mass is density times volume. Okay, so those are those three equations, and it just depends on what values you get based to determine what equation you need to use. But these are your three, your three equations that you need to know. Okay, this triangle can help you remember that relationship. Okay, now it can get a little bit tricky when you are trying to find the density of a solid. Let's say we have a purple rock. Okay, and I want to know the density of that rock. So you need to first figure out the mass, because density is mass over volume. You could put it on a balance and you could record the mass. But then when we're looking at volume, how do you take the volume of a solid? How do you take the volume of a rock? The only way that we know how to take volume is to put it into a graduated cylinder. Okay, so let's say you put that rock into a graduated cylinder. Could you say that this is 5 milliliters, that the volume is 5 milliliters, because it reaches that 5? Well, the thing is that it doesn't completely fill up that area below the 5 milliliter line. So it would not be accurate to say that the volume was 5 milliliters. Okay, so what we can do is something called water displacement. And what we do there is we first fill the graduated cylinder at a certain recorded volume of water. Let's say that we put 10 milliliters of water in here. Alright, so I put 10 milliliters of water in there, and then I drop my rock into that graduated cylinder. Okay, and once I drop my rock into that graduated cylinder, the water is going to rise a certain amount. Okay, so now this is going to be after I drop it in, and let's say, let's say my water now with my rock dropped into it is up to that 20 milliliter mark. Okay, so this is my new reading on my water, and my rock is going to be down there at the bottom. Alright, so water displacement means how much water was displaced, what's the difference between those water readings. Okay, the difference is first I was at 10 milliliters, and now I'm at 20 milliliters. Okay, so the volume of the rock would have to be 20 milliliters minus 10 milliliters. Okay, and so that's obviously going to equal 10 milliliters. Alright, let's say that the rock weighed 5 grams. Okay, the density is mass over volume. So my density is going to be 5 grams over 10 milliliters. Okay? Or 1 over 2 grams per milliliter. Alright, so that's how we look at the density of, let's say, a solid or some irregular shape. You're going to do it by water displacement. See how much water it moves when it goes in and is submerged. Okay, so let's look at a couple practice questions. So what is the density of a marble that occupies 310 centimeters cubed and has a mass of 853 grams? Okay, so the three values that I need are density, mass, and volume. Okay, my density, it says what is the density? Okay, so that's what I'm solving for. The marble occupies 310 centimeters cubed, so that right there, that unit is telling me that is the volume, 310 centimeters cubed, and has a mass of 853 grams. Okay, that is my mass, 853 grams. Alright, so right there that tells me that I have mass and volume and I'm trying to solve for density. So the equation that I need to use is D equals M over V. Okay, I have mass, 853 grams. I have volume, 310 centimeters cubed. Okay, so I need to plug that into a calculator. If you plug it in, you should get 2.7516, and this is in grams per centimeter cubed. Okay, but my final answer needs to have the correct number of sig figs. So we're doing division. We need to look at the two numbers that are involved here. Okay, I've got 310. I need to count, it has 0 decimals in it, so I count in this direction. That has 2 sig figs. And 853, no decimals, so I count in that direction. And that has 3 sig figs. Okay, so my final answer needs to have the least amount of sig figs that are used in the equation, and in that case it's 2. Okay, if I need this to be 2 sig figs, it needs to be that many numbers. Alright, I would not just write 2.7 because I need to look at my rounding rules. The next number is a 5. 5 is going to round the 7 up. Okay, so my final answer for this question is that the density is going to be 2.8 grams per centimeter cubed. Okay, that final answer has 2 sig figs in it. My next question, diamond has a density of 3.26 grams per centimeter cubed. What is the mass of a diamond that has a volume of 0.350 centimeters cubed? Alright, so again I'm going to write the three variables that I need are density, mass, and volume. It tells me the density. It tells me the density is 3.26 grams per centimeter cubed. What is the mass? Okay, so that's what I'm solving for. And it tells me the volume is 0.350 centimeters cubed. Okay, so in this case I'm solving for mass. So I need to use my M equals equation. It's M equals density times volume. Okay, so in this case my mass equals my density, which is 3.26. Times my volume, which is 0.350 centimeters cubed. Okay, if I multiply that out, I should get, you should get 1.141. And I'm solving for mass, so this would be grams. But when I look back at my sig figs, so I have, I'm counting with a decimal, I'm counting in this direction. That first number, that density number, that has 3 sig figs. And my volume, I'm also counting in this direction. This number has 3 sig figs as well. Okay, so I need the least amount. In this case, In this case, I need 3 sig figs in my final answer. And so I need 3 numbers right there. Okay, if I look at my rounding rules, that last 1 is not going to round up my 4. Keep doing that. Okay, so my final answer is just going to be 1.14 grams. Final answer. Alright, my last example here says, what is the volume of a sample of liquid mercury that has a mass of 76.2 grams, given that the density of mercury is 13.6 grams per milliliter? So again, I need my 3 variables, density, mass, and volume. It says, what is the volume? So that is what I'm solving for. What is the volume? That's my question mark. Of a sample of liquid mercury has a mass of 76.2 grams and a density of 13.6 grams per milliliter. Okay, so again, volume, that's my question mark, so I need my volume equals equation. We know that volume equals mass over density. So in this case, it equals 76.2 grams divided by 13.6 grams per milliliter. Okay? If you type that into your calculator, you should get that your volume equals 5.60294411. Okay, and it goes on. And this is my volume, so this is in milliliters. But if we look back at the what the numbers that are used in the equation, this is a decimal number. I count in this direction that has 3 sig figs. And my bottom number, my density number, you count in that direction also, that also has 3 sig figs. So my final answer needs to have 3 sig figs. It needs to have this many numbers. Alright, I look, I could put 5.60, but I need to look at the next number, that 2. Is that going to round up the 0? Well, it's below 5, so it is not going to round it up. So my final answer is going to be volume equals 5.60 milliliters. Okay? That is all. We will do more examples in class, but make sure that you have those 3 equations down for density, mass, and volume.